Hey everybody, this is Craig from Vitex, and today we're going to shine a light on some of the parameters of transceivers. So a lot of us, when we talk about transceivers, we're talking about the data rate and the reach. So that seems like it's a super important parameters that we discuss. But there's actually something a lot more important, and we're going to talk about it today. And that's our wavelength accuracy. So before we get into why that's important, let's just go through a little refresher of what is wavelength accuracy. So from our wavelength, we can find what our frequency is by looking at the velocity over the frequency. So, but it's also important when we talk about the velocity here, we're talking about the speed of light in a vacuum. So it's super important that in these cases, we have to remember our refractive index in here and divide that so we can find what is the speed of the light going through a fiber cable. So just taking, for example, in a single mode fiber, you're looking at a value that's around 1.467. So it's important that you check what your index value is so you can calculate that correctly. When we talk about the accuracy, a lot of times we refer to it as parts per million. So we want to see what our variation is in the frequency. We could just use this really easy formula, and we're looking at our frequency times our parts per million value, say 50 parts per million. We want to make sure that you divide it by 10 to the 6 because we are talking about a unit that is in millions. Okay? So what happens to our accuracy in different situations? So let's take temperature first, because that's one that happens in a lot of telecom environments, especially since these transceivers are used outdoors. So as we see an increase in temperature, we also see an increase in the amount of accuracy. So, and that's actually a bad thing because we want to really keep those accuracies really tight. So we don't want that variation kind of exploding all over the place. So besides temperature, we can actually look at how new a device is versus how old the device is. So if we look at our BOL or beginning of life versus our end of life or EOL, we actually see a very similar trend. So when these are first manufactured, the accuracy is much tighter than it is when it's out in the field and used for a longer period of time. So that's something to keep in mind. So you really want to make sure you talk with your suppliers on some of their accelerated life testing and what their end of life accuracy is in their products. So why is this important, especially in some telecom solutions? So we're going to look at some of the different applications that this is in, specifically CWDM versus DWDM. So we look at these two solutions. One is definitely more important than the other. So we look at our coarse wavelength division. We have typically a supported channel, all the way on the other side, spacing of around 20 nanometers. So we want to make sure our accuracy can support this so our receiver is able to pick up the signals versus one to another. When we look at DWDM, it's a lot more dense. So the light wavelengths are much closer together, around 0.8 nanometers when we talk about a 100 gigahertz ITU grid. So what does that mean kind of like in real life? So if we look at these spacings here, and we're just looking at our delta lambda, we can see one is 20 nanometers versus another one that's 0.8. So you can see in this case, it's much more important for our DWDM to have a much higher and tighter accuracy than the CWDM. So what does this actually mean for an installation? If we look at a DWDM in, say, traditional C-band, right now there's 80 wavelengths that are available. So this kind of translates to an 8 terabit transmission bandwidth. And if we expand that into the extended C range, we actually increase up to 96 wavelengths, which will bring us to 9.6 terabits. So this is a really awesome improvement if we're able to put more of these wavelengths in. And it's really important that the accuracy of all these individual lambdas are really tight. And so make sure you check the specifications on that. Like I said, both at the beginning, the end, and over the temperature range. And until we come back and shine a light on another product, I'll see you then.